In Algebra 2, we've been working with the unit circle. We've started out with this graphic of what the unit circle looks like, and this gives us information about what the different trig functions are based on these angles in standard position as we rotate around. One important thing to remember is that when you're using this graphic is that the x value is cosine of theta, the y value is sine of theta, and I'll also include here that if you recall, we have an identity that says tangent of theta is going to equal sine theta over cosine theta. Now, we're going to use that information to fill in a chart. For some people, using a chart is more helpful than using a graphic like this. So we're going to fill in a chart where we have the angles in degrees and radians. We're going to look at the degree measures in the first quadrant and then do the quadrantal angles after that, and then use information about, for instance, reference angles to work with the other quadrants. So let's start with sine here. We're going to look at this using this chart here to fill in the sine row here. So if we look at sine, and sine being the y value, sine of 0 degrees, here's the y value. I'm going to just circle this so you recognize that's where we're getting it from. So sine of 0 degrees is 0. If I go to 30 degrees up here, I get this y value, 1/2. And so I'm going to put that on my chart. Now if I go up to 45, I'll circle this one also. Here's sine of 45 degrees is that y value. And so I get square root of 2 over 2. And then sine of 60 degrees all the way up here is square root of 3 over 2. And then lastly, sine of this quadrant, sine of 90 degrees is this y value, which is 1. So notice that these values are getting larger as we go on, and that makes sense because sine on a coordinate system is y over r. The r stays the same, so as the y gets larger, as that angle increases through that first quadrant, we're going to expect our sine values to get larger as well. So now let's go ahead and do cosine. So cosine relates to the x value of our ordered pairs. So as we go through these, we're going to start with cosine of 0 degrees. That's the 1 here. So 1 would be for cosine. Next, cosine of 30 degrees is square root of 3 over 2. We're going to do 45 next. Cosine of 45 is square root of 2 over 2. We'll do cosine of 60 degrees, that's our x value here, which is 1/2. And then cosine of 90 degrees is equal to 0. Now, if you look at those values, those are going down in value. And that makes sense again, since cosine is x over r. When the r staying constant, as we go up with the angles here, the x values are getting smaller until they get to 0. Now let's go ahead and fill in the last two here with the quadrantal angles. So if I go to 180 degrees to fill in sine, so out here at 180 degrees, we'll put in 0 for our 180 degrees. And if we come down here to sine of 270, that's y values in -1. So we fill those in. And then if we do the cosine, so cosine of 180 degrees is -1. And then the cosine of 270 is 0. Now what you hopefully notice on this table here is that there's a lot of repetition. And that repetition is due to the fact that sine and cosine are co-functions, meaning that if you have sine equal to cosine, the two angles are complementary. So if you look at here at 30 degrees, its complement is 60 degrees. So the sine of 30 degrees equals the cosine of 60. Just like the sine of 30 degrees, the cosine of 30 degrees, is equal to the sine of 60 degrees. So you've got that relationship with the co-functions that leads to a lot of repetition on this chart that might help you with your memorization of these values. Same thing down here. If if you're gonna look at the repetition here in these values on the quadrant angles, those usually though, I think more of, I usually use the idea of the x and the y, and at 90 degrees, the y is increased, the x is 0, so that helps me there. On the 180, the y is 0, the x is increased to be equal to the r, so the opposite of the r, so we get the -1 and so on. That might help you on the quadrants. Now, the next part I want to have, I'm gonna demonstrate an idea here, and then I'm gonna want you to fill in parts of this chart. So if we're looking at tangent, we're gonna use the fact that tangent is equal to sine over cosine. So if we look at these different values, if we look at sine over cosine, so sine over 1, 0 over 1 is equal to 0. So we've got that for our first value here. So we have a 0 here. And if we start going up with 30 degrees, I'm going to demonstrate this one, and then I want you to fill in the rest of this table so that you can check to see how you're doing on this idea. So the next one, if we want to do tangent of 30 degrees, I'm going to put sine of 30 degrees, I'll just do it up here, sine of 30 degrees over cosine of 30 degrees to get tangent of 30 degrees. So sine of 30 degrees is equal to 1/2. Tangent, or cosine of 30 degrees is square root of 3 over 2. You might remember from the work we've done with fractions that if you have a fraction in the denominator, you bring it up top and multiply by the reciprocal. So this is going to be equal to 1/2 times 2 over the square root of 3. The 2's cancel. You end up with 1 over the square root of 3. Now you have to rationalize that, so I'll write that here. We want to rationalize the denominator by multiplying by square root of 3 over square root of 3, and you get square root of 3 on top, square root of 9 on the bottom, which is just equal to 3. So the tangent of 30 degrees we've just calculated to be the square root of 3 over 3. That's the value for it. Now I will fill in just one more for you. I want to go down to the tangent of 90 degrees. Just a reminder, if tangent is sine over cosine, 1 over 0 is undefined. We don't know that value. You can't divide by 0. So if you're dividing by 0, remember to just put an undefined in that answer slot of the row. So what I'd like you to do now is pause the video. I'd like you to try these to fill in the rest of this row for tangent, see how you do with that, and then I'll come back and I'll share with you the answers to it. If you're still looking at this video and you haven't filled in these spots, I'd like you to take some time, go ahead and pause your video, fill in these last 4 blanks in the tangent. Now that you've completed that task and you've filled in this row, check your answers here. Here are the values for tangent when we take tangent of each of these angles based on them being sine over cosine. Now the next 3 are going to be a little bit easier, so I'm going to start you out on these, but I'm going to expect you to try again to fill these in. The reason why these are a little easier is that each of these are reciprocals of ones above. So if you look at this, for instance, cotangent is the reciprocal of tangent. So if I'm doing this cotangent row, the reciprocal of 0 is, say, 1 over 0 is undefined. So this will be undefined. So the reciprocal of 0 is what that turns out to be. I want to do the reciprocal of square root of 3 over 3. Well, this one I'm going to look back to my work up here. Remember we originally, when we were doing tangent of 30, we got 1 over the square root of 3. Well, it's better to just do the reciprocal of that rather than of this one, because then you'd have to rationalize the denominator again and reduce. So up here, the reciprocal of square root of 3 over 3 is just the square root of 3 over 1, which is the square root of 3. You can do the same thing for secant. Okay, I'll just write that over here. This is 1 over tangent secant, remember, is 1 over cosine. And lastly, the cosecant, that's going to be 1 over sine. So what I'd like you to do is pause the video, look at these first 3 lines, do their reciprocals, and fill in the rest of this chart to see how you do on the reciprocals of these 3 trig functions. All right, now that you've completed that task of filling in the rest of them, let's check over your answers. Look over these to see how you did. You might even need to pause just to check on it. Hopefully you're like me as a good math student. Hopefully you're using a pencil, because there will be times that you might make a mistake and you need to change it. And see if you've got these values and check to see that you've done reciprocals, rationalized denominators, things like that. So now that we have this chart, you can see all the patterns that are taking place. When you look at the comparison between sine and cosine, you see a lot of repetition. Between tangent and cotangent, you see a lot of repetition. Secant and cosecant, a lot of repetition. Along with the relationship between things like cofunctions, angles that are complementary, and also reciprocals. Use that to help guide you in how you can know how to fill in this chart. Let's do some examples. Let's do looking at some examples from just doing some standard trig functions and values. Now that we've created our chart, let's go ahead and do some standard problems with some of these angles and simplify them. So let's look at this one here where we've got 2 sine pi over 4 cosine pi over 4. Let's fill in the numbers from our table here. So sine, we got pi over 4, sine of it is square root of 2 over 2. Cosine, since 45 is its own complement, cosine of pi over 4 is also going to be square root of 2 over 2. So we're going to get 2 times the square root of 4 over 4. So if we multiply that, I'm going to get 2 times, this is going to be 2 over 4. 2 times a half is equal to 1. So that simplifies to 1. Now let's look at cosecant of 5 pi over 3. Now 5 pi over 3 is not on our table. So what you might want to do is get familiar with reference angles. And what I'm going to do is convert this first of all to degrees. You don't have to if you're very familiar with your radian values. But if we multiply this by 180 over pi, pi's cancel. You end up with the 3, by the way, will reduce with the 180 and give you 60. So 5 times 60 gives you 300 degrees. So this is a 300 degree angle. This is the same thing as cosecant of 300 degrees. Well, again, 300 degrees is not on my table. So what do I use? I'm going to go ahead and use my reference angle. If I do 300 degrees, I get right over here into the 4th quadrant, or 300 degrees. What's left is a reference angle here of 60 degrees. So the angle with the x-axis gives me a clue. I'm going to go up here and use the 60 degree angle along with cosecant, or if I don't want to memorize all of these, I could use the sine and its reciprocal. So what I'm going to get for this one is I'm going to find the cosecant of 60 degrees, that reference angle. Now I do have to consider, is cosecant positive or negative in the 4th quadrant? Well, you might know it several different ways. One way to think of it is, since cosecant is the reciprocal of sine, sine is negative in this quadrant because it's y over r. Y is negative below the axis. So this is going to be a negative value. Some people use a memorization tool like saying all students take calculus. Cosine's positive in this quadrant and its reciprocal secant, but all the other ones are negative in that quadrant. So sine and cosecant are negative in the 4th quadrant. So now I look up cosecant of 60 degrees. I've got that right here. That's 2 square roots of 3 over 3, and I put a negative in front of it. And so that's how I can use this table to get that value of what cosecant of 5 pi over 3 is, and I went through the process of converting to degrees, using my reference angle, and knowing what positive and negatives were, as well as reciprocals. This next one, number 3 here, this one looks like you're going to put in a lot of work unless you notice right away that tangent and cotangent are reciprocals of each other if they have the same angle. Notice they both have 5 pi over 6 and 5 pi over 6. So these two are reciprocals, and what happens when you multiply reciprocals? You get just 1. So this one's a quick problem. If the angles are the same and the trig functions are reciprocals, then you can just multiply them together and get 1. Now what happens though if we do a problem like this where they're not the same angle? So let's do tangent of 5 pi over 4 and cotangent of pi over 3 and multiply those. Well, let's go to our table. Tangent of 5 pi over 4, pi over 4. Here's pi over 4. There's tangent of pi over 4 is equal to 1. So I can get 1 on this one. And then cotangent of pi over 3, go back up to my table here. Here's pi over 3. Cotangent is equal to square root of 3 over 3 on that spot. So I'm going to have 1 times the square root of 3 over 3, and that gives me just the square root of 3 over 3. So we've used a lot of information in this video. We've used all of our identities that we've talked about, things like reciprocal identities, cofunctions. We talked about in which quadrants trig functions are positive and negative, but most importantly, what we've done is we've taken this graphic of the unit circle, we've translated it into a chart, and we're going to use that chart to look for patterns to help us know these values better, even sometimes have them memorized.